Welcome to Physics Can Be Fun with me, Stephen Thomas. Today I'd like to talk about a forum for physics people. Here you see it. It's on googlegroups.com. Let's give you the actual URL. You see physics spelled F-I-S-I-C-S-P-H-U-N. Physics Fun. It's on the googlegroups.com and it's where they host their different forums. So it's called F-I-S-I-C-S-P-H-U-N. It's the wrong spelling of physics fun. And on this forum, we have our group here, which has got, it says here, welcome all Matric grade 12 physics learners and teachers, the general public interested in physics and chemistry. Here is the place to ask questions and receive help through your Matric year. And we'd like you to come and post your questions on our forum. Get help. I'm here to help you. So anybody in Matric or grade 11 or teachers even who have questions regarding the syllabus, come and ask them. So now I've posted a whole lot of threads, and today we're going to be doing chemistry, acids and bases. So today's video I will place here under chemistry, question 7. It's question 7 of the physics paper 2, acids and bases. So let's go and have a look at question 7. Here we see it, and I'm just going to move this up a little bit. Sulfuric acid is a strong acid present in acid rain. It ionizes in 2 steps as follows. So here we see H2SO4 aqueous dissolved in water liquid goes to form the hydronium ion aqueous plus HSO4 minus. So there you see it's lost one of its hydrogens in the form of an ion to there. And let's not forget that a hydrogen ion is simply a proton. So it's lost a proton. And then the second stage is this ion, HSO4 minus, plus water, and it loses that hydrogen to this water and it forms H3O plus another hydronium ion aqueous, and then we're left with the sulfate ion SO4 2 minus aqueous. Define an acid in terms of the Lowry-Bronsted theory. Now, like I said, I only know that if you want to do better in your exam, suppose you did lousy in June and you want to do better in September and really well in November, work through past papers. That's the closest you're going to get to the future paper. And I said you can get these past papers from WCED past papers. Google it. Western Cape Education Department past papers. Right, so let's have a look at what the memo says for, I've got their data sheet. We'll have to scroll through that. Let's have a look what it says. And let's suppose there's the definition. An acid is a proton donor. Simple enough. Let's go back to the question. So Lowry-Bronsted, even if you knew nothing, you could say an acid is a proton donor from that. Remember it. This is like a way of learning. Write down the formula of the conjugate base of H3O plus aqueous. Now let's suppose again you knew nothing, and the conjugate base is water, they say. So I will say that there's certain questions you can just memorize the answer and you'll do okay. This is actually one where you need a little bit of help, and that's why I'm here to help you with this. So what is a conjugate base? You've got to look for something that looks like this, H3O plus, but it's something that a base is not a proton donor, it's a proton gainer. And look at water. Water, if it gains a proton from this, will go and form the hydronium ion H3O plus. So water, something that looks like H3O plus, is the conjugate base. So what is when you're told to look for a conjugate base, look for something that looks almost like that, but minus one extra proton. So that would be water. Write down the formula of the substance that acts as an ampholyte in the ionization of sulfuric acid. Ampho sounds like amphibian. Amphibious means both. So it's going to be something that is both an acid and a base. So something that's halfway between H2SO4 and SO4. And what is the answer? Let's go and have a look on the memo. I have to scroll through. and you'll see it's HSO4 minus. So it's halfway to losing, it's lost one proton, it can lose another proton, but it's an amphiolite in that it can also gain another proton and again form sulfuric acid, or it can form the sulfate ion. So I say this question you actually do need a little bit of help with. Now it says here, acid rain does not cause damage to lakes that have rocks containing limestone, and tells you calcium carbonate. You must read these questions carefully. Hydrolysis of calcium carbonate results in the formation of ions which neutralize the acid. Now, if they ask you to define hydrolysis, well, you've done hydrolysis in your substitution, elimination, etc. reactions, but if you don't know, you look at hydro, water, lysis, splitting. Splitting of what? Something in the presence of water. So it's adding water to a salt which will split the salt. So let's look at our answer. Reaction of a salt with water. It says accept reactions of cations or anions with water. What I'm going to say is just don't bother to remember that. Just go for the standard answer. And frankly, this is where you need a little bit of help, because in the next question you don't want that, you want this answer. That's the most acceptable answer. It's the answer I would give. So let's go to that next question. It says here, define hydrolysis, explain with the aid of the relevant hydrolysis reaction how limestone can neutralize the acid. So you do want a reaction that contains limestone. Luckily, they give you calcium carbonate, and it's going to be neutralized, and it's going to neutralize the acid. So you need some way in which that calcium carbonate can form what neutralizes an acid? A base. What does a base contain? OH minus, or the hydroxyl ion. So you want to go from that calcium carbonate to, through the addition of water, they've told you, to something with OH minus. So you've got to have a reaction that's got calcium carbonate, water, and OH. And let's go and look at the memo. There's your calcium carbonate plus water goes to form OH minus. Now, let's give you a hint. Calcium carbonate, you must get used to seeing it as calcium and carbonate. Calcium and carbonate. And think of water as H and HO, or OH. So it's OH with another H is water. And there's where you're going to get your OH from, that water, and that's going to leave you with a hydrogen. So this hydrogen is going to go, let's just draw it here, those hydrogens are going to then go across to that carbonate and form carbonic acid, H2CO3, and that's going to leave you with an OH there and calcium hydroxide, CaOH2. Calcium's in group 2, it's got two hooks. OH has got one hook or one valency, so it takes two of those to combine with one of those. I quite like the way they're going in these exams. So they're actually requiring you to know some basic chemistry. This is not standard acid-base stuff. They are asking you to create a base, calcium hydroxide. So you're looking for something that's got OH here. And so you've got to create it yourself, and there is the reaction. Let's go back to the next question. So, explain with the aid of the relevant hydrolysis reaction how limestone can reduce the acid. I just want to see if we gave the reaction, and what do they say here? The formation of OH minus neutralizes the excess acid. Okay, so that's all that you had to write. So there was the reaction. Then you said the OH minus, which is a base, will then neutralize the sulfuric acid. Fine. So let's go back to our question, the last question, which is worth quite a lot of marks. This is in fact worth 10 marks out of 20. So acids and bases, quite a big section. it says the water in a lake has a pH of 5. Now, if you go to your BFF or your best physics friend, so we see here on our BFF or on the data sheet, pH is the negative log of the hydronium ion concentration, H3O plus. So here it is. We see it here on our data sheet, and it's next to these formulae which we might use. We're going to use that formula in the next question, in the next part of this question. So it's with these formulae on stoichiometry. Okay, so pH is the negative log of H3O plus ion concentration. So calculate the concentration of hydronium ions in the water. Let's just get a text box here. So pH equals the negative log of, in brackets, the hydrogen ion concentration H3O plus concentration. So that is what pH is. Negative log of the hydrogen ion concentration. Now what you've got to be able to do is you've got to be able to go from a pH of 5 to the hydronium ion concentration. So how do we do it? Well, you go to your calculator, and let me just go and find my calculator. Applications, calculator. Right, there's the scientific calculator. We type in 5, we make it negative, and what is pH? It is actually that. So find that on your calculator. It is normally the second function of that, and there it gives you a hydrogen ion concentration or a hydronium ion concentration of 0.00001. And you've got to get used to, for example, how do you go from that back to 5 and play around with it. So 5, take your pH, turn it into a negative, and there you go. Or if you want to go back, hit that button and play around, because what if they give you a pH of, say, 3.2? You're going to do the same thing. You're going to turn it into the negative, raise it to the power of 10, and there's going to be what your hydrogen or hydronium ion concentration is. And if you're given the hydronium ion concentration, you're going to turn it into a pH. You're going to do that, and there's you're back to your pH. So please play around with it. Fine. So let's get back to it. The water in the lake has a pH of 5. Calculate the concentration of hydronium ions in the water. Well, we've done that with our calculator there. So let's just have a look at what they do. pH is the negative log. There, a mark for that. The pH they give you is 5. And so we end up with 1 times 10 to the minus 5, which is the same as our calculator answer. Then the second part of that question, it says here, so we've calculated the concentration for 3 marks on the calculator. The volume of water in the lake is 4 times 10 to the 9 decimeters cubed. Lime or calcium oxide is added to the water to neutralize the acid according to the following reaction. Nice, they give us calcium oxide plus water goes to form calcium, 2 plus ions, and 3 waters. If the final amount of hydronium ions is 1,26 times 10 to the 3 moles, calculate the mass of lime that was added to the lake. So we know that we've started with a certain concentration, and we've worked that out in question 7.3.1. We could convert that now to the number of moles. If we've got a concentration and we've got a volume, we can have a formula where we can work out the number of moles that we start with. We are told the number of moles that we end with, And if we subtract what we end with from what we start with, we can then find how many moles disappeared. Then looking at this equation, we can see the ratio of that to that is 2:1, and we know that we're going to have to do something with those ratios. So why don't we start by saying we know the concentration of the lake. Let's find the number of moles of H3O plus at the start. We know the number of moles at the end. Let's find how many moles disappeared due to the neutralization reaction. So let's go to the memo and see what they did. So here they're telling us we must choose a formula, we must substitute the volume, we must include the volume, and we must find the number of moles. So let's see which formula they choose. Concentration is number of moles over volume. I would choose that formula. And you say concentration of the hydronium ion is number of moles over volume. We've calculated from the pH at the start what the number of moles was, what the concentration was, which was that, 1 times 10 to the minus 5, is number of moles over the volume which they gave us, and then we calculate the number of moles to be 4 times 10 to the 4 moles. Fine. Now, that is 4 times 10 to the 4 moles of H3O plus. But what does that mean in terms of this formula? Look, they are asking, calculate the mass of lime that was added to the lake. They're not asking us the concentration of that. So for 1 mole, let's just do this. For every 1 mole of calcium oxide, 2 moles of that are involved. So if we found that 2 moles of this disappeared, 1 mole of that would have to be added. So we're halving the amount of moles that disappeared in the neutralization. I don't know if that makes sense to you, but the ratio of that which we've calculated, number of moles of that which we started, we ended, we worked out by subtracting the 2 how much of that was involved, then we must use half the amount of calcium oxide. So let's go to the formula. And so here we're going. If we know that the number of moles of that is that, to start with, we subtract that at the end. So we went from pH to concentration to number of moles of hydronium ions was that, minus that at the end. That is how much disappeared in the process. But because that is to that is a half, we're going to say half of that, and there's the number of moles of calcium oxide was used up. So it's going to be half the number of moles of hydronium ions. And so half of 3,87 is 1.94 times 10 to the 4 moles was used up. I hope that's helped you to understand how to do the problem. This problem you definitely needed a little bit of help before you could memorize it, I would say. But now, once you've mastered this, you kind of got an idea, or if you read through it again or watch this video again, you know the method, so it's going to be much easier. And just learn one method. So for example, you're just going to put a line through that. You don't want to learn that, and you don't want to learn that. You're just going to learn that. Choose one method that's going to suit you. And the same for all of these. Just scratch out and so now it becomes a much easier task to learn your one answer to this question. And now you're equipped for any kind of question you get in the final exam that's at all like this. So I would definitely go through past papers and join our forum. So this video is going to go onto the forum. All videos on this final paper, 2018 Matric final paper, is going to be in this forum, and then you can ask questions, or if you've got related questions, you can put them under, for example, question 7, which is the acid base. Anything under to do with acid and base will then go on our forum. Don't forget our forum. There's our forum, and we're going to put it under question 7, acid and bases. This is where this video will go. And any questions relating to acid and bases, come to our forum, googlegroups.com, physics fun, and ask your questions, invite your friends, tell your teacher, get everyone involved in coming to this new group and asking questions. Thank you for watching.